Look at the second derivative now. So there is a second derivative test. So the first derivative, right, we could find our critical numbers, and then we could find where we're increasing and decreasing and find extrema. With the second derivative, we can find the concavity of the function. So if the second derivative is positive, then the original function is concave up. The second derivative is negative, then the original function is concave down. And this time, if there's a sign change in our critical numbers, then we have a point of inflection. Okay? I realize there's a typo that says convex, and I need it to say concave. So, alrighty. Let's see, determine the open intervals for which the graph is concave up or down, and then state the point of inflection. Alrighty, so we need a second derivative. So to find the second, we need to find the first. So that's going to give me x squared minus 1. And then the second derivative is going to be 2x. So find my critical points here. So that's just going to be x equals 0. So I can do a sign chart again and test values. Now the multiplicity rule still applies. But we can also just test values. If I plug in a negative number, I'll get negative. If I plug in a positive, I'll get positive. So that's that second derivative. So that means on the original function, I'm concave down and then concave up. So I'll just put up and down from 0 to infinity and down from negative infinity to 0. And then we have a point of inflection at x equals 0. We can find the actual ordered pair by plugging in 0 into the original function, which will give me 0. So the point of inflection is at 0, 0. All right? So point of inflection, we can try and find them by if the concavity changes, and we look at whether the second derivative is 0 or undefined. So, all right, determine any points of inflection and discuss the concavity of the graph. So I need to find the first derivative to find the second. So 4x cubed minus 12x squared. And the second derivative will be 12x squared minus 24x. If I set that equal to 0, I'm going to factor a GCF of 12x out. I'm left with x minus 2. So my values are 0 and 2. All right, can go with the multiplicities again. They are odd, so it's going to cross at every point. So I'm just going to use x equals 1. 12 times 1 is positive, and 1 minus 2 is negative. So in the end, that is negative. And then we flip-flop. So up and up. So, all right, we are concave up from negative infinity to 0 and 2 to infinity, and then down from 0 to 2. And then we do have some sign changes. So points of inflection at x equals 0 and 2. And we could get the actual points, but I don't think we need to for right now. All right. Let's look at another one. So find the inflection points and the intervals of concavity. All right, so find the first derivative to find the second. So 15x squared plus 4x minus 3. And then 30x plus 4. Find my critical numbers. So I would subtract 4 and divide by 30. And I can reduce that, right? What, 2/15? All right. 0 is a nice number to work with. If I plug in 0, I'm just left with positive 4. Multiplicity was odd, so it'll switch. So, all right, we're concave up from negative 2/15 to infinity and down from negative infinity to negative 2/15. Okay. We also can use the second derivative to find extrema of the function. Okay, so if x equals c is a critical number of the function, then that means the first derivative is 0 or the first derivative doesn't exist. So that makes that critical number a possible maximum or minimum. So I'm going to fill out this chart here. So if the second derivative is positive, that means the original function is concave up. And that means the first derivative is increasing. If it's negative, we're concave down and decreasing. But we're neither positive or negative, so really that means we're equal to 0. Then we would have to use the first derivative test to analyze. Okay, so there's a possible point of inflection here, which means there's a possible max or min. Now we're not sure. We just use that first derivative. So, all right, let's see if we can use the second derivative to find the relative extrema. So what I want to find is the first derivative first. So 4x cubed minus 24x squared. And I want to find those critical numbers. So I'm going to take a GCF of 4x squared out. And I'm left with x minus 6. So I get 0 and 6. And now I'm not doing a sign chart for this. What I am going to do is we got 0 and 6. So we want to find the extrema. So I want to know what the value is on the function. So I'll plug in 0, I'll get negative 5. If I plug in 6, I'm going to have to put that in a calculator. 6 to the 4th minus 8 times 6 cubed minus 5. It's going to give me negative 437. But what I really want to do is test it in the second derivative. Okay, because the second derivative will help tell us what is happening. So let me find the second derivative. So that's 12x squared minus 48x. And then just for sake of making these a little easier, x minus 4. If I plug in these values now, so if I plug in 0, then I'm going to get 0 times negative 4, which is 0. If I plug in 6, I'm going to get, I'm just looking for signs here, so positive, and 6 minus 4 is positive, so I get a positive number here. So I can confidently say that there's a minimum at 6, because if the second derivative is positive, it means the graph is concave up, right? So there's a minimum. So minimum at 6, negative 437. But based off second derivative test, no conclusion on x equals 0, because it gave me 0. I could look further, but I'm not going to. All right. I think I'll fill out this chart, and then this curve sketching, we definitely are doing this in a totally different section. So I'm going to stop it after I fill out this chart here, because curve sketching is something totally different. Well, it's the next lesson. So, okay, so if my first derivative is positive and my second derivative is also positive, then we are increasing and concave up. In fact, if the first derivative is positive, then we're increasing anyway. If the second derivative is negative, then we'd be concave down. And then if the second derivative is equal to 0, we're increasing, and there's probably a point of inflection. The difference in this column is instead of increasing, we're decreasing because that first derivative is negative. So decreasing and concave up. And then we're decreasing and concave down. And decreasing and point of inflection, right? Now, if the first derivative is equal to 0 and the second derivative is positive, then we have a relative minimum and we're concave up. And then we'd have a relative maximum and be concave down for the next one. And then this last one, if the first derivative is equal to 0 and the second derivative is equal to 0, then the function itself is, we call it smooth or level, right? And then there's a possible point of inflection. All right. And then that's going to be all for the second derivative test. And then, like I said, curve sketching is going to be in a separate one. So if you have any questions, let me know.